So the next thing we need to understand about the IP addressing is network and host portions. Now again, whatever the addresses we have, like we have 4 portions of addresses, 1 2 3 4, and this portion are further classified into 2 parts, like network part and host part, or we can say network portion and host portions. Now when we say network, when we say host, it's a single device in the network. Let's take an example. I got a set of devices connected in the LAN, and each and every device in the network, it can be a computer, it can be a router, it can be any other device, will be identified as a host. We call one single device as a host, and whatever the address we assign to that device, we call it as host address. And then a network address actually identifies a network. Set of devices or group of devices identifies a network, and whatever the portion which is representing a network, it identifies the complete network but not identify a single device, whereas host part is actually identifying a single device in that particular network. So but if you try to observe here, the network portion and the host portions are actually varying in different classes. Like in the A class there is only one network portion, but in the B class there are 2 network portions which identifies a network, and in the C class we have 3 network portions which identifies a network. Let's try to understand why or how exactly we need to use them in identifying the network and the host. So if you just go back with a simple example, like if you take any flat numbers or the hotel room numbers, generally the numbering in the hotels room numbers, generally it will be like this: 203, 204, and then 305, 306, 310, something like this. So now in this, the first part, whatever the first part we'll see, now this actually represents a specific floor. So mostly here, whenever you say 203 means, we'll say the first 2 represents as the second floor, and on that particular second floor it's a room number. Okay, so that's how it identifies. Okay, so similar way here, so on that particular floor you may have more than one room, like you may have 201, 202, 203, 204, like that, but at the end there will be one common part, and that common part is going to identify the floor, and the one part which is not common, which will be identifying a specific room on that particular floor. Now it has something, a slight relation here. In case of network and host also, one single device, a room is more similar to the host, and whereas the floor part is more similar to your network, and the addressing also more similar, not exact, it's a more similar kind of thing. Let's try to understand how it will be in case of addressing in IP addressing. So let me take an example. I got 2 computers in my LAN, and they both are connected with each other, and the IP address of the device is 192.168.1.1 is the IP address of this device, and the IP address of the another device is 192.168.2.1. Okay, so my requirement is, I want to ensure that these 2 devices should communicate with each other, should ping with each other. I want to check. Now to check that, the first condition is they should be on the same network. Now my question is whether they belong to the same network or different networks. So just like I have taken an example of floor numbers, if I ask you 201 and 305, do they belong to the same floors? So the answer is simply no. They are not on the same floors, they are different floors, because the floor part or this part is not same. If it is not same, in that case we call it as different networks, because this is on the second floor and this is on the third floor. Now similar way here also, it will be identified based on the network portion. Just like we see the floor part, here also whether these 2 devices are in the same network or different network, that will be identified based on the network portion. Now before I decide how many network portions, I need to identify the class. Now this address belongs to which class? As per the range, C class, 192 to 223. 192 to 223, which class it is? C class. In C class, how many network portions? I got 3 network portions. Now in order to be the same network portion has to be same. So this is 192.168 one dot network, and this is 192.168 two dot network. So network portions are different, so which means they are on different networks, they are not on the same networks. So here the same network or different network will be decided based on the network portions, and it varies based on the class. Now it is not like this one, the floor numbers are like that, where you will have only the first number represent the floor. But in case of IP addressing, it can be 3 numbers represents a network, it can be 2 portions, or it can be 1 portion represents your network. So in case of A class, we must compare only 1 portion. Now in case of B class, we need to compare 2 portions, and in case of C class, we need to compare the first 3 portions. So based on that, we need to identify these things. Okay, so network portion, 2 host portions, 3 host portions. Okay, so this is how we need to tell. Now in my scenario, even though I can say these two belongs to they might be physically in the same location, but they are logically not same. They are logically different because they do not have the same network portion. So in order to have a communication, they should be physically in the same location, and LAN wise they should be in the same LAN, and also they should be logically in the same networks. So they will become logically same if they have the same network portions. So that's how we need to identify. So this is very important thing we need to know. If you are designing any network, any campus network, any small network also, if you don't follow this proper addressing methodology, or if you don't understand this basic rule, in that case you will end up in having no connectivity between the devices. Now these two devices, they will not talk to each other. Whatever you do, they will never talk to each other because they are logically different networks. Okay, so let's go ahead with some more examples to have some more better understanding on this particular things. Like I can go with one more example. I got 2 computers, and this is 172.16.10.10, and this is 172.16.12.12, 12.10 or 12.12. Now I'm getting the same question here, whether they belong to the same network or different network. First, identify the class. So the class is 128 to 191 belongs to B class, and it's a B class address. In the B class there are 2 network portions. In order to be in the same network portion has to be same. Now here they are same, so we call them as same networks. Why? Because the network portion, there are first 2 portions are network, now they are same. So let's take one more example. I'm going to write one more example here. Let's say 10.10.10.10 and 10.12.10.10, something like this. Now by seeing itself, we can say they are in different networks, because first thing we need to identify this, it's an A class address because it's from 0 to 127, A class range. In the A class there is only 1 network portion. Yep, 1 network portion. In order to be in the network portion, it will be same. Sorry, I said different, but it's they are in same networks. Now why they are in same network? Because we just need to compare only the first portion. In case of B class address, we have to compare the 2 portions, and in case of C class, we have to compare 3 portions. So all the 3 portions has to be same in order to be in the same network in case of any C class examples. Okay, in case of B class, 2 portions has to be same, and in case of A class, 1 portion has to be same. The next thing, let's take one example. So now based on this, we are going to design a very small network here, and we'll try to understand how exactly when we design the network, what are the things we need to keep in mind. So let's take an example. I got 200 devices in the LAN, and I did all the physical connections. Everything is done, physical connection through switches in the LAN. All the 200 devices are connected and it's working and it's fine. But simply connecting the devices will not allow the communication process, because what is the next step? We need to assign the IP address, because without assigning the IP address, how we are going to identify the devices? So for identification, we need to have an address, and we call it as IP address. Okay, so now the question is, 200 devices you want to connect, that's okay, but the question is, do you want them in the same network or different network? So let's say my requirement is they must be in the same network and they should communicate with each other without any problems. So but according to our rule which we discussed just now, in order to be in the same network we must have the same network portion. So if you don't have a same network portion, in that case what happens? There is no communication by default, because if the network portion is different, it will be treated as different networks. Okay, so we need to make sure that they should be in the same networks. Probably I have decided to go with any C class address. So if I'm going with any C class address, in that case we need to keep in mind that my requirement is all the devices must be in the same network. So whatever the C class address I'm using, let's say I'm using 192.168.10 dot, I have to ensure that this first three portions has to be same till the end. I cannot change this, because if I change them it will become a different network, and if it is becoming different network then they will not communicate with each other. I can change only one portion, that is host, because in the C class there are three network portions and one host. I can go from 0, 1, 2, 3, 4, 5. I can go up to maximum of 255. Okay, so because I cannot go beyond 255, and that's it. You can only write the addresses starting from 192.168.10.255, where the first three portions has to be the same. So which means according to this rule, in a C class address maximum we can have 256 devices connected in the LAN, because you can see if you count all the addresses here starting from 0 to 255, we can have only 256 addresses. Okay, so what if my requirement is beyond 256, or in the future I have 200 devices, maybe this 200 might become 300 in the future. Possibilities there. My manager says that maybe in the future we might add some 100 more computers. So design in such a way that we don't need a renumbering of readdressing, something like that. In that case I can go with some B class address, because the B class address supports more number of addresses. But when you think B class is having two network and two hosts, right? So which means we need to ensure that the first two portions has to be same till the end. We need to say 172.16. We need to ensure that this 172.16 should be same till the end. We cannot change that, and we can only change the remaining two portions. We can start from 0.0, 0.1, 0.2, and I can go up to maximum of 0.255. So is it finished? It's not yet finished, because after this we can write as 1.0, and then we can write as 1.1, and I can go up to 1.255. Similar way I can write 2 dot, 3 dot, 4 dot, 5 dot, 6 dot, like that I can go up to 255.255, the maximum last number. So the first two portions will remain the same, there is no change in that, but the remaining two portions we can keep on changing, and when we keep on change it will go up to 255.255, like that we can write. So which means in case of B class address we can write around 256 square addresses, almost around 65,536 addresses. So we can get around 65,536 addresses in any B class address. That's the size of the network. So if I just compare the same thing with the A class network, in A class it has to be more, because in A class there is one network portion and remaining three are host portions. Okay, so which means I can take any one portion, let's say 10, and this 10 has to be same till the end. We cannot change, because if you change that particular 10 it will become a different network. We can only change the remaining three portions because they are host. We can only change that, and then we can write as 0.0.1, 2, 3. I can go up to 0.0.255, and then I can write 0.1.0, like that I can go up to 0.255.255, more similar to B class, and then I can continue the same thing with 1 dot again. I can write everything with 1 dot, like that. Maximum I can go up to 255.255.255. So I'm not writing the complete range, but you have to understand that how we write. So which means in the A class network you get 256 cube addresses, almost 16, 16, 777, 212, 216, 167.216 somewhere around. There's a round figure number, around that number you will get. So in one network, in case of A class, you'll get these many addresses, whereas in case of B class, we get 65,000 addresses, and in case of A class, we get 256 addresses. Now what's the difference? Why we are getting a different size ranges? So why? Because of the number of host bits. Like in case of A class, we have one network portion and 3 host portions, and in case of B class, we got 2 network and 2 host, and in case of C class, we have 3 network and 1 host portion. So by default, there is only 1 host portion. In case of C class, we got 8 host bits, so 2 to the power of 8, it is 256. And in case of B class, we have 2 host portions, which means each portion is having 8 bits, so it becomes 2 to the power of 16, so 65,536. When it comes to A class, we got more host portions, 2 to the power of 24, because 3 portions are host, so it will be 16 million, somewhere around that number. So the more number of host bits we have, or host portions we have, or we can say host bits, we have more number of available hosts available for that, or more number of devices we can connect. So to have a different variable sizes, so to meet a different size requirements, there is a classification of network and host with a different sizes, different network and different host portions. So there is no uniform network portions or host portions in all the 3 classes. They vary because to have a different network sizes. So that's the main intention of making different network and the host portions in your IP addressing.